Okay, this is the first lesson in your next unit. It's called Arithmetic and Geometric Sequences, and then we will be leading into linear equations. So what you're going to learn today is how to find the terms of an arithmetic sequence and how to find the terms of a geometric sequence. Here's some of the vocabulary. You'll be learning about what a sequence is, arithmetic sequences, terms, common difference, geometric sequence, and common ratio. And what you really need to know is that a sequence is an ordered list of numbers. You've probably experienced these in the past where you kind of pick up on the pattern and write the next three terms. Well, now we're going to kind of just define that a little bit more for you, because in an arithmetic sequence, it's the sequence in which the difference between two consecutive terms, called the common difference, is the same in the sequence. So you might be able to pick up the pattern, and one way to test for this is to subtract the previous term from the term. So take 30 minus 23, and you see that the difference is 7. Then test out 23 minus 16, which is also 7. And 16 minus 9, and 9 minus 2. Since there is the same common difference in each previous term, between the two terms, the common difference, or we'll call it D, is equal to 7, and to find the next three terms, you would just add 7, add 7, add 7. In a geometric sequence, the sequence is one in which the quotient of any two consecutive terms, which is called the common ratio, is the same. So in this sequence, 1, 4, 16, 64, and 256, the common ratio is 4. And you can tell that because you could take 256 divided by 64, and you would get 4. And you would take 64 divided by 16 and get 4, and take 16 divided by 4 and get 4, and take 4 and divide by 1 and get 4. So this is that common ratio, also known as R, which is 4. And to get the next three terms, you would multiply by 4, and then multiply by 4, and multiply by 4. Alright, so now we're going to get into a couple examples. You're going to be looking at them. The types of questions I will be asking you is mainly to determine if it is geometric or arithmetic, but in this case I'm just specifically asking you if it is arithmetic, and if it is, state the common difference and write the next three terms. So in this example, still example 1, you would subtract to find the difference, and we see that 11 minus 7 is 4, and 7 minus 3 is 4, and 3 minus that negative 1, remember your integer addition is to change them both to positive, is 4, and then your negative 1 minus a negative 5, which is like negative 1 plus 5, and that's also 4. So yes, it is arithmetic, and the common difference is a positive 4. And the next three terms would be 15, 19, and 23. Okay? In this example, tell if it's arithmetic, and if it is, state the common difference and write the next three terms. So if you subtract to find the common difference, 20 minus 12 is 8, 12 minus 6 is 6, 6 minus 2 is 4, and 2 minus 0 is 2, it might form a pattern. However, it would not be an arithmetic sequence because it doesn't have the same common difference. Therefore, it's not arithmetic. State whether the sequence is geometric, and if it is, state the common ratio and write the next three terms. So try it out. Divide 16 divided by 16, 16 divided by 8, 8 divided by 8, 8 divided by 4, 4 divided by 4, and you can see that it is not geometric, it does not have a common ratio, so you don't have to write the next three terms. Looking at this one, we want to see if it is geometric? And if it is, state the common ratio and write the next three terms. So with your division, a third divided by -1 is a negative third. A -1 divided by 3 is a negative third. 3 divided by -9 is a negative third. And -9 divided by 27 is a negative third. So it is geometric, and the common ratio is -1/3. So if you take 1/3 and divide by -1/3, you get -1/9, then 1/27, then -1/81 for the next three terms. So in this one, we want to state whether each sequence is arithmetic or geometric or neither. And then state the common difference, common ratio, and write the next three terms. All right, so here we go. So you can test it out to see how it's changing. For number 3, I could test out, and I find that 15 minus 11 is 4, 11 minus 7 is 4, and 7 minus 3 is 4. So we'll call that arithmetic, and that D is equal to a positive 4. So the next three terms would be 15 plus 4, which is 19, 19 plus 4, and 23 plus 4. Okay. For number 4, you could take and try to do and see if it's arithmetic. So 27 minus 9, and then 9 minus 3, and you can see that there's too much of a discrepancy. So you could try to divide. 27 divided by 9 is 3, 9 divided by 3 is 3, and 3 divided by 1 is 3. So we would call that a geometric sequence. And in this case, R is equal to 3. So 27 times 3 is 81. 81 times 3 is 243. And 243 times 3 is 729. For number 5. Again, you could try subtraction. So 18 minus 12 is 4. 12 minus 8 is 4. And then 8 minus 6 is 2. So it's not going to be arithmetic because it's not this common difference. But if you take 18 divided by 12, you get 1.5, and 12 divided by 8 is 1.5. So we'll call this geometric. And R is equal to, and you can use decimals, you could use fractions, whatever you want. So the next three terms would be 18 times 1.5 would be 27. 27 times 1.5 would be 40.5. And 40.5 times 1.5 would be 60 3/4. For number 6, so let's see, -2 minus 3 is -5, 3 minus 8 is -5, 8 minus 13. So it is an arithmetic sequence, and D is equal to -5. So if you take -2 plus -5, you'll get a -7, -12, and then a -17. For 7, you know, when you're dealing with fractions like this, sometimes it's best, especially if you're going to try to add or subtract them, to get common denominators. So you could change this 3 to actually 9/3, because 9 divided by 3 is a positive 3, and this could be a 6/3. And so to try to find the difference, 6 thirds minus 7 thirds is negative 1 third. 7 thirds minus 8 thirds is negative 1 third. And 8 thirds minus 9 thirds is negative 1 third. So this is also arithmetic sequence, and D is equal to negative 1 third. 4, 8. You could try some subtraction, but we're going to have some, it doesn't look like the difference here and here are the same. So let's try some division. So 3/4 divided by 3 and then 3 divided by 12 and then 12 divided by 48. So I get geometric, and R is equal to 1/4. So the next three terms become 3 over 16, 3 over 64, and 3 over 256. So it's probably best to keep things in fractions to keep the decimals from getting out of hand. And finally, when dealing with this problem with the car, it says that the new car is worth about 0.82 or 82% of its value from the previous year during the first 3 years. Approximately how much will a $20,000 car be worth in 3 years? And since it's depreciating at a constant rate for those 3 years, you could find that by multiplying the 0.82 times 20,000. So we would call this a geometric sequence. And since it started out at, if I need to write it, I'll write it up here, 20,000, and then times the 0.82 would be 16,400, and then 13,448, and finally 11,027 and 36 cents. And R would be equal to 0.82.